Hi everyone, Mr. Boltri here bringing you video 3.7, where we're going to talk about the lab that we're going to do in the next class, which is going to be the force of gravity lab. So first, let's talk about what is the force of gravity? Well, the force of gravity is the force that is the pull between any two objects that have mass. So for example, I have mass and the bowling ball right there has mass. So technically, I am pulling the bowling ball close to me and the bowling ball is pulling me closer to it. Except for the kind of wrinkle in this is my mass on a grand scale is really, really, really small. And the bowling ball mass is also really, really, really small. So the gravitational force between us is so small that we can ignore it. But if we look around for objects that have more mass, and I'm not talking about like the mass of a building or the mass of a bus, I'm talking about like ginormous amount of mass. The only really force of gravity that we need to worry about around us is the force of gravity by the Earth on us and everything around us. And all the other force of gravities between two massive objects like me and the bowling ball are so small we can ignore it. And the word for that is negligible. But the Earth, because it has so much mass, is pulling us down towards the center of the Earth. But according to Newton's third law, if the Earth pulls us down with a force of gravity, then we also pull back up on the Earth with a force of gravity. And believe it or not, those two forces are equal in magnitude and opposite in direction. Because even though I have a small mass, the Earth has a big mass. So the interaction force between us, sort of the pull back and forth, the force is equal. Now, that does not mean that the consequences of that force are equal. Because I have such a small mass, that force pulls me down. Because the Earth has such a big mass, it doesn't even barely even notice, like at all, at all. So the Earth has a lot of mass and pulls things that have mass down towards it. That's the big thing that I need you to remember from this. And so now that we have kind of a baseline understanding of the force of gravity, we're going to talk about the lab that we're going to run in our next class, which is the force of gravity lab. So it's been a while since we've done this. So I'm going to ask that you flip to a brand new page in your lab notebook. And it's really nice if you can have both sides of the page right by each other. So our graph can be right next to our data. And then we're going to write down the question, draw a sketch, write a procedure, make our data table. And then by doing that, we will be all 100% ready to run our lab in the next class. So the question for this lab is pretty simple. It's just going to be, what is the relationship between force, gravity, and mass? So we said that objects that have mass get pulled down by gravity. So I'm curious to see if we increase the mass, how does that change the force gravity? And so in order to do this, we're going to need a couple tools. And let me zoom in on this sketch so you can make your own. So we have a ring stand that's going to sort of hold our force sensor up high. And then we have a force sensor, and that's what we're going to be able to use to measure the force. And then we're going to have a hook on it so we can stack some masses and steadily increase the mass on the force sensor. And that will allow us to see the relationship between mass and force, specifically the force of gravity. So make sure you get a labeled sketch down into your lab notebook, which includes at least all of these four things. And so the last thing you might want to include is an electronic balance, which will allow us to figure out the mass of the masses, but also the masses will be labeled. So we'll know how much mass each one of them is, but it wouldn't be bad to include an electronic balance just to check the mass of all of the masses. So once you get that sketch down, now you're going to write a procedure about how you're going to collect all of the data. But first, let me talk you through how to use the force sensor, because you've never really done it on your own in class. And then that'll help you write a procedure. So here's how you use a force sensor. We're going to put the force sensor on the ring stand. Remember, we have to attach it to the LabQuest Mini, which is our translator. It allows the readings from the force sensor to be understood by the computer. Then we're going to open our computer and launch Logger Pro. So make sure you have Logger Pro downloaded. And this is very important. Make sure you've brought your USB adapter to class, because that's the only way we're going to be able to plug it in to our laptop. So then once we get everything set up, you can then add your force hook to your force sensor and start adding masses on top of that. So let me show you what it's going to look like when you connect the force sensor to Logger Pro. You're going to get a window that looks like this. And the most important thing I'd like to draw your attention to is the force reading, which is down in the bottom left. So oftentimes when you just plug in the force sensor, it's going to be reading some force. It might be positive, it might be negative, but often it's not going to be zero. And that's just because sometimes when they're in the box, the force sensors get jostled around. So we need to make sure to zero our force sensor so that at the beginning is reading 0 newtons. By the way, I haven't talked about this before, but newtons is a unit of force, much like pounds, but we're just going to be measuring stuff in terms of newtons. So in order to do that, you see that there's no force on the force sensor. So right now it should be reading 0, but it's not. So in order to do that, we're going to press Command 0 and then wait 5 seconds. Make sure you don't touch the force probe while you do that. Command 0 is going to zero out the force sensor. And then after you've done that, it should read 0. This is 0.001, and it's hard to get it to be exactly 0.000. So 0.001 is close enough to 0 for our purposes. So after you zero the force sensor, then you can add your force hook onto it. Don't forget to press play so you can get a nice graph that shows, okay, so when I add the force hook, there's some jostling at the beginning, but then it settles in. But this is a little bit small, so don't forget the handy dandy auto scale button at the top, which will allow you to see a little bit more. So this is, so I kind of bumped it when I was putting the force hook on. And then you'll notice that it has a pretty constant force, like right around 0.5. But then the question is, well, what number should I write down to my lab notebook for how much force there was? Well, I could write down this number, but you'll notice that when you run the experiment, this number tends to wiggle around just a little bit, which you can see in your graph, there's kind of a wiggling. And so it's kind of like a little bit confusing as to which number to write down. And I think the best way to approach it is to highlight the section that you want to analyze, and then use the statistics button, because when you press that, if you've highlighted the section, then it will give you the average reading in that area. So the average is the mean. So then you can write down 0.4912 if you want to be super accurate, or honestly, we're good if we just round it to 2 decimal places. So 0.494, and that's in terms of newtons for the average reading of the force. So now that you understand a little bit more about how force probes work, I want you to write your own procedure. And when you do that, remember, it's not acceptable to say collect data. You need to write down exactly what you are going to measure and how you are going to measure it. So pause the video now and write your own procedure, which we're going to look at together in our next class. And then just to finish up our video, we need to make our data table, and we're just going to be recording mass and force gravity. And then we are going to have our graph where we're going to graph mass and force gravity. So this kind of, you make sure that your lab notebook is all set up to run our lab in the next class. You don't have to like add numbers to your graph yet, since we don't have numbers yet. But make sure that everything is set up in your lab notebook for our next class so that we can come to class and hit the ground running and have conduct and analyze the lab all before the end of class. But for now, this is Mr. Boltri wrapping up video 3.7, where we introduce the force gravity lab that we're going to run in the next class. Let me know if you have any questions, and go Bears.